All right, EXAIR is a manufacturer, direct seller, and a global distributor of engineered point-of-use compressed air products. We are located in the northeast corner of Cincinnati, Ohio, where we were founded in 1983. All product designs focus on the efficient and safe usage of compressed air. Our products are commonly used in cooling, cleaning, static elimination, and conveying processes. In fact, you may be familiar with some of our products like super air nozzles, vortex tubes, cabinet coolers, or industrial vacuums, just to name a few. We also offer the largest selection of end-of-use intelligent compressed air products on the market today. A little bit about myself. My name is Jordan Schaus. I'm one of the application engineers here at EXAIR. I joined the team here in August of 2018. Before that, I spent my time in the metrology field, examining my customers' quality processes, and then designing and implementing a strategy to better the quality, reduce scrap across the board. When I'm not here at EXAIR, I like to explore the outdoors. So much so, I have a 100-gallon reef aquarium in my house, and of course, spending time with my fiance and our crazy dog. Much of our focus here at EXAIR is to improve the overall efficiency of industrial compressed air operating processes. Over the course of the next 30 to 45 minutes, I'm going to cover one of the most important topics to protect sensitive electronics that can fail due to heat or environmental contaminants. There are various methods used in industry to dissipate heat loads within an electrical cabinet. Knowing the best option to handle difficult environments while offering a low total cost of ownership and optimal functionality will help keep your production running while saving money. Unwanted heat can cause an enclosure's internal temperature to exceed the manufacturer's recommended rating for electrical equipment installed inside. There are two main heat sources that add up to make the total heat load, one being the internal heat sources, such as AC drives, servos, power supplies. Ironically, the same equipment that can be damaged by is creating the very own heat. External heat sources are mainly dictated by the environment in which the enclosure is located. These sources include engine rooms, industrial ovens, and even solar heat if the enclosure is located outdoors or in direct sunlight. At higher temperatures, the efficiency of equipment decreases. It may cause component damage or failure. For example, a modern VFD typically has an efficiency of 93 to 97% and is designed to operate below 95 degrees Fahrenheit. For every degree increase above the maximum intended operating temperature, efficiency is derated by 2%, in addition to the risk of equipment failure. It is important to properly match a cabinet cooling solution to your unique application to verify it will properly meet your needs. During this webinar, we're going to discuss the 5 popular options for electrical cabinet coolers. These options include air-to-air heat exchangers and filtered fans, liquid-to-air heat exchangers, thermoelectric, refrigerant-based, also referred to as compressor-based AC systems, and EXAIR's cabinet cooler systems. To fully explore our top 5 cabinet cooling options, we're going to focus on these 5 key factors. Install, the initial unit cost. What does it cost to purchase the product? Installation, how many hours will it take to install? Maintenance, how many hours a year will you spend performing maintenance on the cabinet cooling solution? Operation and performance, how much does the solution cost to operate, considering the electricity usage and or the compressed air usage? And how well does it perform? And the total cost of ownership. We're going to add all of that up and give you an estimated yearly cost of ownership. So the first one we're going to talk about today is air-to-air, including the filtered fans. So heat pipes in an air-to-air heat exchanger cool enclosures by using evaporative cooling to transport thermal energy from one place to another via evaporation and condensation of a coolant. Heat pipes transfer heat through a phase change of a coolant, similar to a compressor-based conditioner, except they have no moving parts other than fans. The lower section of the heat pipe assembly is in contact with the heated air from the electrical enclosure. This heat causes the refrigerant to change phase and vaporize. That vapor then flashes to the top of the pipe, which is in contact with the outside air. When the outside air temp is lower than the enclosure temp, the refrigerant vapor gives up the heat to the outside air and returns to a liquid. The liquid then falls to the bottom and the cycle starts again. As long as there is a negative temperature differential between the inside and outside air. In layman's terms, air-to-air heat exchangers cannot cool the enclosure lower than the ambient air temp. So the ambient temperature needs to be controlled. And if circulation fans are a wear item that can lead to a premature failure or cabinet overheating. Filter fans, they force ambient air into an enclosure, usually mounted towards the bottom of a cabinet and exhaust towards the top to remove the hot air. This is by far the cheapest option for cooling cabinets, but this method can only cool to a temperature of the ambient air as well. Filter fans also have a possibility to blow environmental contaminants inside the cabinet and call for frequent filter cleaning and replacement. So the upfront purchase price of this air-to-air heat exchanger is around $1,450. Spreading that cost over the manufacturer's expected service life of 10 years, we come up with a $145 cost per year. Using 3 hours as the minimum to install and a service rate of $65 an hour, spreading that over the manufacturer's expected service lifetime of 10 years, we come up with $1,950 per year. Using 3 hours as the minimum for yearly maintenance and a service rate of $65 an hour, we have a yearly cost of $195 for maintenance. The next expense into the total operation is the electricity draw. We calculate that off of the running watts of the product, 5 hours a day, 5 days a week, 9 months a year, at 8.5 cents per kilowatt hour. We come up with a value of $5.51 a year. The total cost of ownership per year coming in at $365.01 per year. This does not include production downtime for repairs on the product. This will be the cheapest option we talk about today, but considering the limitations on the cooling ability, we consider them the lowest in usability. Next, we'll talk about liquid to air. Liquid cooling is usually turned to when air to air doesn't have the required heat removal. Due to the cooled liquid, liquid to air can get below ambient temperature, unlike air to air. With liquid to air cabinet cooling, the air within the cabinet is cooled by flowing a cold liquid through a heat exchanger and distributing the air within the cabinet via the heat exchanger's fan. The cabinet cooler may receive the cold liquid from facility water or a chiller or another heat exchanger. Water inlet tip is assumed to be 68 degrees Fahrenheit in most cases, so some sort of secondary service is needed to provide that cold liquid. Again, we're talking about the cost. The upfront purchase price for this unit was $1,275. Spread that over the manufacturer's expected service lifetime of 10 years, we come up with $127.50 per year. Using 3 hours as the minimum to install and a service rate of 65, spreading that over the manufacturer's expected service lifetime of 10 years, we come up with $19.50. Using 4 hours as the minimum for yearly maintenance and a service rate of $65, we have a yearly cost of $260 per year. Now to figure out the electricity draw, we're going to calculate that off of the running watts, 5 hours a day, 5 days a week, 9 months a year, at 8.5 cents per kilowatt hour. We come up with a value of $2.75 a year, with a total cost of ownership coming in at $409.75, not including production downtime for repairs. It's also good to note that the water inlet temp is typically assumed to be 68 degrees Fahrenheit, so water costs are not taken into account, and it's assumed to be a closed loop system with a chiller or some kind of cooling tower. The chiller and cooling tower equipment is also not included in this price. Thermoelectric. The underlying phenomenon behind thermoelectric cooling system is known as the Peltier effect. This effect is harnessed by using two elements of a semiconductor material upon application of a direct current, DC power source. The device transfers heat from one side to another. The side the heat is taken from becomes cold, and fans blow air against the cold surface, distributing cold air around the cabinet. The major disadvantage to the Peltier effect is that it's inefficient. The flowing current itself tends to generate a significant amount of heat, which then gets added to the overall heat dissipation needs. The upfront purchase price of this thermoelectric cooler is $4,450. Spreading that over the expected service lifetime of 10 years, we come up with $445 a year. Using 3 hours as the minimum to install, service rate is $65 an hour, and spreading that over the manufacturer's expected service life of 10 years, we come up with $1950 per year. Using 4 hours as the minimum for yearly maintenance and a service rate of $65 an hour, we have a yearly cost of $260. Next, going into that total cost is the electricity draw. We calculate that off of running watts, 5 hours a day, 5 days a week, 9 months a year, at 8.5 cents per kilowatt hour, we come up with a value of $190.03 a year. A total cost of ownership coming in at $914.53 a year, not including production downtime for repairs. Now, refrigerant-based units. All air conditioning systems utilize a specific material that undergoes a phase change process. That material, also known as a refrigerant, is contained within the tubing throughout the air conditioning system. The refrigerant is pulled into the system's compressor in the form of a warm vapor after leaving the evaporator coil. The compressor increases the density of the incoming refrigerant vapor, causing it to increase in pressure and temperature. This hot, high-pressure vapor then travels to the condenser, where it moves through a series of coils with thin fins attached. A fan blows over the fins, and heat moves from the refrigerant to the fins into the airstream, and then is vented outside of the system. Now that the vapor has lost a significant amount of heat, it changes phase to a gas, from a gas to a high-temperature liquid. This liquid is then forced through an expansion valve that causes the liquid to form a mist. The cold mist travels from the evaporator coil, which is then located in the airstream, to the circulation fans, which pulls air from within the building. The air then goes across the cold coils, which pulls heat from the air, causing the air to cool, then circulate around the cabinet. The transfer of heat to the refrigerant causes it to change back into a warm vapor and enters the compressor to begin the cycle again. Refrigerant cooling systems are capable of higher cooling capacities, but come with much higher maintenance costs due to the amount of moving wear components. The upfront purchase price of this refrigerant-based unit is $3,290. Spreading that cost over the manufacturer's expected service lifetime of 5 years, we come up with a $658 per year cost. Using 3 hours as the minimum to install, a service rate of 65, spreading that over the 5-year service lifetime, we come up with $39 a year. Using 6 hours as the minimum for yearly maintenance and a service rate of $65 an hour, we have a yearly cost of $390. The final expense going into the total operation cost is the electricity draw. We calculate that off of running watts, 5 hours a day, 5 days a week, 9 months a year, at 8.5 cents per kilowatt hour, we come up with a value of $70.38 a year. The total cost of ownership per year coming in at $1,157.38 a year, not including downtime and production for repairs. Now on to EXAIR Cabinet Coolers. How do cabinet cooler systems work? Compressed air enters the vortex tube powered cabinet cooler and is converted into 2 streams, one hot and one cold. Hot air from the vortex tube is muffled and exhausted through the vortex tube exhaust. The cold air is then discharged into the cabinet through the included cold air distribution kit. Then the displaced hot air in the cabinet rises to the exhaust to atmosphere through the cabinet cooler body. The control cabinet is then both cooled and purged with cool, clean air. Outside air is never able to enter the control panel. The upfront purchase price of this EXAIR cabinet cooler system is $770. Spreading that over the manufacturer's expected service lifetime of 20 years, we come up with $38.50 a year. Using 1 hour as the time to install, the service rate of $65 an hour, spreading that over the expected service lifetime of 20 years, we come up with $3.25 a year. As long as condensate and particulate-free air is supplied to the EXAIR cabinet cooling system, there are no maintenance needs to keep it running at peak performance. The next expense going into the total operation cost is the electricity draw. We calculate that off of the compressed air usage. 5 hours a day, 5 days a week, 9 months a year. At 25 cents per 1,000 cubic feet of air, we come up with a value of $338 a year, which gives us a total cost of ownership per year coming in at $379.75. Here's a visual chart to explain the temperature and environmental conditions of each of the cooling systems performed best in. EXAIR cabinet coolers exceed BTU per hour characteristics of most. They exceed the maximum operating temperature of most and can withstand the harshest conditions while still producing a very low total operating cost. EXAIR's compressed air operated cabinet cooling systems are a low cost, reliable way to cool and purge electronic control panels. There are no moving parts to wear out, and no filters to replace, eliminating the need for constant monitoring. NEMA Type 12, 4, and 4X models are available that are very compact and mount in just minutes through an ordinary electrical knockout. Available in a wide variety of cooling capacities, ranging from 275 BTUs per hour for our smallest unit, up to 5,600 BTUs per hour for our largest dual system. Thermostat control systems are the most efficient way to operate a cabinet cooling solution, as they limit compressed air use by operating only when the temperature inside the enclosure approaches critical levels. Continuous operating systems are recommended when constant cooling and constant positive pressure inside of a panel are required. In addition, EXAIR Cabinet Coolers systems are also UL listed and CE compliant. Cabinet coolers mount to the enclosure through a drilled hole or a standard electrical knockout. The NEMA Type 12 cabinet coolers may be mounted on the top or the side of the panel, while the NEMA 4 and 4X cabinet coolers must be mounted on the top of the panel or on the side of the panel in a vertical position to maintain their NEMA integrity. If there is a need to mount a NEMA 4 or 4X cabinet cooler on the side of the cabinet, we do offer a side mount kit to make this possible without impacting the NEMA integrity of the cabinet. You can see that in the right photo. Thermostat controlled cabinet cooling systems are the best option when experiencing fluctuating heat loads caused by environmental or seasonal changes. Thermostatically controlled systems include a cabinet cooler, adjustable thermostat, solenoid valve, a cold air distribution kit consisting of tubing, self-adhesive clips to duct the cold air inside the panel, and a filter separator to remove any water and contaminants from the supply. The adjustable thermostat is a bimetal electromechanical switch, factory set for 95 degrees Fahrenheit. We chose this setting because, as we discussed earlier regarding some of the more common devices found in a panel, like VFDs, this meets the recommended set point by the manufacturer. It will normally hold a plus or minus 2 degrees Fahrenheit temperature inside the cabinet. It's rated for 120 to 240 volt AC or 24 volt DC. The thermostats are UL recognized and CSA certified. They are not position sensitive, but should be located in a hot area inside the enclosure through a 7/8 knockout through the enclosure wall or on a bracket inside the panel. We also offer the ETC, or the electronic temperature control, providing precise temperature control via a quick response thermocouple. It can accurately maintain a constant temperature that is slightly lower than the maximum temperature rating of the electronics, allowing for just enough cooling without wasting compressed air. The temperature setting can be easily changed by a simple push of a button, and the temperature is displayed on the LED screen. The control activates the included solenoid valve when the temperature setting is exceeded. The ETC is suitable for NEMA 12, 4, and 4X environments. EXAIR also offers special cabinet cooling solutions for even the most advanced and complex applications. Better yet, they are all stock items as well. Special high temperature cabinet cooling systems are available for areas where ambient temperatures range from 125 degrees Fahrenheit to 200 degrees Fahrenheit. Upgraded internal components are able to withstand higher temperatures, like those near boilers, ovens, furnaces, just to name a few. We offer systems ranging as low as 1,000 BTU per hour up to our largest dual system, providing 5,600 BTU per hour of cooling. Non-hazardous purge cabinet cooler systems are the preferred choice for areas with high contaminants that may pass through a conduit or small openings in the panel. The non-hazardous purge cabinet cooling systems apply a constant small amount of positive pressure into the enclosure by passing 1 SCFM of air through the cabinet cooler when the solenoid valve is in the closed position. When the thermostat detects high temperature, the solenoid valve is energized to pass full line pressure and volume to the cabinet cooler, providing the full rated cooling capacity for the system. EXAIR's hazardous location cabinet coolers are engineered for use with purged electrical enclosures. The Hazlot cabinet coolers are not purged and pressurized control systems and should not be used in place of a purged and pressurized controller. They are meant for use in conjunction with a purged and pressurized control system. These systems have been approved and tested by UL for use in the following areas. Class 1 Div 1, groups A, B, C, and D. Class 1 typically refers to the presence of a flammable gas or vapors in quantities sufficient to produce an explosion or ignitable mixtures. Class 2 Div 1, groups E, F, and G. Class 2 areas are locations in which combustibles may exist. The end user shall avoid installation of the device in a Class 2 environment where dust may be readily disturbed by the exhaust of the cabinet cooler. Any dust formed in the vicinity of the cooler must be cleaned regularly. And Class 3. Class 3 areas are locations that will have ignitable fibers or filings present, very common in the textile industry. The cabinet cooler also carries a temperature rating of T3C, meaning it cannot be installed near any materials that could auto-ignite at temperatures in excess of 320 degrees Fahrenheit. Where should you look to install a cabinet cooling system from EXAIR? Here are a few common applications where our cabinet cooling systems can help solve heat-related issues. Programmable controllers, relay panels, CNC systems, computer cabinets, laser housings, electrical scales, high heat environments, dirty areas, and even hazardous locations. Just to name a few. Why should you consider a cabinet cooler system over another method of cooling? Well, the advantages are pretty clear. They're low cost, they're compact, they're quiet, they install in minutes, and they can maintain your NEMA 12, 4, and 4X cabinet rating. They stabilize temperature and humidity, no moving parts, so they're maintenance free. They eliminate any safety concerns or OSHA violations. They mount in standard electrical knockouts. They stop nuisance tripping, stop heat damage, eliminate fans and filters, eliminate lost production, stop dirt contamination, and provide washdown protection. Heat within an electrical cabinet can be a major issue for manufacturing companies. The costs associated with downtime and repairs on sensitive electronics that fail due to the heat and environmental contaminants is an unnecessary burden. Today we have talked about various methods to use in industry to dissipate heat loads within an electrical cabinet. But here at EXAIR we designed a solution that will work in every environment and save you time and money. Now, selecting the proper cabinet cooling system can be simplified by using our cabinet cooler sizing guide. The sizing guide collects all the pertinent information needed for an EXAIR application engineer to determine the heat load that will be needed to dissipate and ensure the most efficient cooler is chosen and the proper NEMA rating is selected to fit your particular requirement. Under the handout section of your control board, you will see there are two documents that you can download, one being the cabinet cooler sizing guide and a copy of EXAIR's full cabinet cooling catalog section. Please download these now if you'd like. If you have any questions, please send them via the questions now, or you can give us a call at any time and we'll do our best to address them. In closing, EXAIR has a full team of subject matter experts that are available to help with your applications. Feel free to reach out to myself or any application engineer for assistance with any questions you may have. Thank you for joining and have a great rest of your day. And now we will start to go through any questions you have, so please send those in. Okay, I got one. What is the temperature range for the ETC? So the ETC is adjustable from 80 Fahrenheit up to 120 degrees Fahrenheit. So approximately 27 Celsius to 49 degrees Celsius. Will EXAIR Corporation cabinet coolers cause condensation inside our control panels? No, the cold air produced by a cabinet cooler and introduced into the enclosure expands to atmospheric pressure and warms the enclosure temperature. Only if humidity from the ambient air is allowed to get into the panel, there will be a potential for condensation. Therefore, it is imperative that all openings are closed off. It's truly a sealed cabinet. On initial startup, the cooler will purge out warm and moist air outside of the panel. As the cool air generated from the cabinet cooler enters the panel, it begins to pick up the heat and relative humidity drops. Can I use this in conjunction with fans already installed on my panel? No, EXAIR's cabinet coolers are designed to be used on a sealed panel like we just spoke about. The cabinet cooler actually has a built-in vent to allow that hot air to escape from the cabinet. If any of the humidity from the ambient air is allowed into the panel, there is a potential for condensation. So it's very important that it is a sealed cabinet. Why do I need the cold air distribution kit? Well, the cold air distribution kit allows the cabinet cooling system to distribute the cold air throughout the cabinet. This is needed because the cabinet cooler itself is self-exhausting. This means all of the air that is put into the cabinet by the unit is exhausted through the body of the unit itself. In order to ensure that you are allowing the cold air to properly cool the cabinet, only warm air is being exhausted, you will want to utilize the cold air distribution kit to carry that cold air away from that exhaust port. Can the thermostat be adjusted to maintain the internal temperature different than the preset 95 degrees? Yeah, in order to do that, you'll just need a liquid at your desired set temperature, a continuity meter, and a small flathead screwdriver. The process is pretty easy, and it's well documented in the installation and maintenance guide. This is a pretty common question: is how much compressed air will the cabinet cooler system consume? The air consumption will depend on the BTU per hour dissipation of the cabinet cooler itself. For example, the 4804 SS, which is a NEMA 4 275 BTU per hour cooler, it will consume 4 SCFM at 100 PSIG, while our largest 5600 BTU per hour cooler will consume 80 SCFM at 100 PSIG. And was like the last one I have here is, will a cabinet cooler system operate at less than 100 PSIG? Yes, the cabinet cooler system will operate at less than 100 PSIG, but the cooling capacity will be decreased depending on the inlet pressure. It is recommended to operate the cabinet cooler at 100 PSIG and at the needed volume for it.